Okay, good morning, class. Today we're going to be talking about risk. And risk is nothing but the variability of return. How much do we actually expect that we would not get the return that we are looking for? That is risk. So, any deviation from this expected return or what we anticipate to get is measured as risk. Now, try and understand before the modern portfolio theory, risk was not even a consideration while investment decision making. Right? Rather, Markowitz, when he first started reading the books of investment decision making, he was surprised that all decisions were based on the returns of the investment, and no consideration was given to the fact that the returns varied across periods and across assets. So he introduced the most basic statistical concept of measure of risk, that is standard deviation, as in how much does the actual observations deviate from the mean. So standard deviation for a population is xi, that is the observation, minus the mean of the observations square divided by n. That is the formula of variance. If we take the under root of that, we get standard deviation. Now try and understand this. The sum of difference of all observations from its mean is 0. Meaning that if we only take the difference of the mean from the observation and add them all together to see the difference or the degree of variation from the mean between all the observations, the total would always be 0. So statisticians came up with a clever solution. They said, let's square the difference of the mean from the observation before we add it. What this did, it converted the negative numbers into positive, still giving us a degree of variation, a measure of degree of variation, at the same time not giving us a non-zero answer. Now we take that across different number of observations for different means and different samples and populations. So we average it across that. So it is x minus mean square, because we don't want a 0, which is a mathematical fact that the sum of deviations of all the observations from the mean is always 0. So to overcome that limitation, we always take it as square. We average it out divided by n. Thereby, we are basically calculating variance this way. But some statistician came up with the logic that if we are taking a square of the deviations, we should underroot it as well. And that's where standard deviation came from. So in the case of sample, we take a degree of freedom of n minus 1 because we don't actually know what the total population is. Right? Other than the basic denominator of n minus 1, the entire formula remains the same for the sample as well as for the population. Okay, so here's a basic numerical. So we talked about dividend yield in the last class. It is nothing but the dividend earned divided by the share price of that year. So the dividend in the year 2013-14 is 13 rupees, and the share price at the end of the year is 604. The dividend yield would be 13 divided by 604 into 100, which would be 21.15%. Capital gain yield would be the difference in prices divided by the base year prices. So it would be 604 minus 466 divided by 466 into 100. That will be the capital gain yield. The sum of the dividend yield and the capital gain yield would be the total return. Now to calculate the variance or the standard deviation, what we need to do is we need to find out the average of all these observations. So we will add all the returns and we will divide by the number of returns that we had. That is we have 5 observations, but because we are talking about the sample here and not the population, we will take it as n minus 1. So it would be 4. The denominator here would be 4. Right? The average would be taken normally, but I'm talking about the n minus 1 factor that we take in the formula. So for example, we will add all the returns and then we'll divide by 5, which will give us the value of 26.86. Right? Now we will take the deviation of this mean 26.86 from every observation. From the first observation 31.77 minus 26.86, 46.25 minus 26.86, and we will keep squaring these deviations and then add them. And then divide them by n minus 1. The n is the number of observations that we had. The number of observations that we had were 5. So n minus 1, 5 minus 1 would become 4. So if we just do that, we'll get the variance. And if we do a under root of that, then we'll get the standard deviation. Right? Now try and understand, the greater the standard deviation, the greater the risk. Because the greater the variation is happening across the mean observation. Right? Now try and understand that we can also incorporate into this scenario some kind of expected return and the probability of getting that return. So for example, this is the case that we have here. We have share price, we have dividend yield, that is dividend divided by the share price into 100. We have capital gain, that is the change in the share price. The initial share price, as you can read towards the top, is 261.25. So the first scenario that we are building, we are expecting a high growth and we are expecting a return of 305.5. That is the end price of the share. So the difference between 261.25 minus 305.5 divided by the base, that is 261.25, into 100 will give us the capital gain yield, that is 16.9%. Right? The sum of that would be the actual return that we are expecting. So here what we have done is we have created a series of expected returns. When we say we have created a series of expected returns, what this allows us to do is that it helps us within one time period to create different expectations from the same stock under different economic scenarios. So for example, what we can start doing here is we can start assigning probabilities to the expected outcome. So the expected rate of return is say 18%, 10.1%, 1% and minus 6%. So these are calculations that we have done, and we have said that okay, if there is growth in the economy, then we can expect a rate of return of 18.5%. If there is expansion in the economy but not in the sense of growth, then we can expect 10.5%. If there is stagnation in the economy, then we can expect a return of 1%. And if the economy actually declines or goes into recession, we can expect a return of minus 6%. Right? Then depending on how likely that outcome, that return is expected to happen, we can give it probabilities. In this scenario, we have used the simple, we have given them equal weightage for 4 different scenarios we have built for the same year, and we have given them equal weightage of 0.25. So now the expected return would be the weighted average return based on the probabilities. So first what we will do is that for every return that we have, we will multiply it by the probability of getting that return. So it will be 18.5 into 0.25, 4.36, 10.5 into 0.25, 2.62, and so on and so forth. So we will add all these products or weighted average of the probabilities and get the answer 6. Now the sum of probabilities is always equal to 1. So we need not divide it by the weight. But what we are basically doing here is we are taking the product of the expected return into the probability, and then we are basically taking out the weighted average of those expected returns. Right? So what we will get now is ER, that is expected return, which is 6%. Right? So ER is nothing but return 1 into probability of return 1 plus return 2 into probability of return 2, so on till Rn into Pn, and then add them across. So Ri into Pi summation across all observations would be our expected return. Now, given our expected return, we can also calculate variance. That is how much we are expecting the actual return to deviate from the expected return. Right? So we had built scenarios of 18.5%, 10.5%, 1% and minus 6%. Right? Now we in the previous step calculated the expected return, that was the weighted average of probabilities of the return that was expected. right? So that came out to be 6%. Variance in this case would be simply the actual return that we are anticipating in each scenario, that is 18.5, 10.5, 1, minus 6, minus the expected return that was 6%. So the expected return was for all the scenarios combined. Now we are seeing in different scenarios what is the variation of this actual overall expected return from the actual return that we are anticipating. So all this is a game of anticipation. We are anticipating different economic circumstances, and based on that we are anticipating different returns. But even in this anticipation, we can compute the basic risk that is there within that investment. So first we took those individual returns that we had expected. We multiplied them by the probability of getting them, added them across to get expected returns or ERs. Then now we take the difference of the respective year's return minus the expected year, square it and multiply into the probability of getting that return. So for example, it is 18.5 minus 6%, that was the ER, square into 0.25 because the probability of getting that return was 0.25. So on and so forth, and we have added them all across to get 86.375. Then we have taken the under root of the standard deviation, under root of the variance to get the standard deviation. Thank you, class.